To begin, we're going to rewrite each of the terms into the constant and its variables. So we're going to have negative 121 as the constant, x to the fifth and y to the fourth as the variables, plus 55 as the constant, x to the first, y to the sixth as the variables, positive 77 as the constant, x to the first, y to the third, and z to the first as our variables, and negative 22 as our constant, and x to the first and y to the first as our variables. Now we can factor out each of the constants. So if we begin with negative 121, we'll get negative 1, 11, and 11. For positive 55, we're going to get 5 and 11. For 77, we're going to have 7 and 11. And for negative 22, we're going to have negative 1 and 2 and 11. So we're looking for things that are found in each of our factors, and we have an 11 found in each factor and nothing else matches up, so we can move to our variables. Can we divide every term by x to the 1? We can. Can we divide every term by x to the 2? No. So we're going to go back and include x to the 1 as a common factor. Moving on to y, can we divide every term by y to the first? We can, but when we get to y squared, we can't. So again, we go back and we add y to the first as a common factor. And can we divide every term by z to the first? No, there's only one term that has z. So our common factor ends up being 11xy. To rewrite our expression, including that common factor, we're going to do that by saying, well, we have 11xy times the quantity, and then it's our entire expression with each of the individual terms divided by that 11xy. Once we've divided each of the terms by 11xy, we can clean that up and we will end up with our final answer. So each of the individual terms from our expression, we need to divide by 11xy to indicate that we're going to be moving that outside the parentheses without changing the value of the expression. And so our final answer is going to be 11xy multiplied by the quantity negative 11x to the fourth, y to the third, plus 5y to the fifth, plus 7y squared z minus 2.